everybody. My name is Aleksis Liekna. I'm from Scope Technologies, and this evening I will talk about accident reconstruction. So the contents of the presentation will be as follows. I will first introduce myself and the company I work for, Scope Technologies. Then we'll talk about accident reconstruction. I will introduce to it. I will introduce you also to changes in market demands, evolution of accident reconstruction, and accident playback in 3D. I will also talk about displaying spatial information in 3 dimensions and physics in accident reconstruction. So let's begin about me. So my name is Aleksis Liekna. I have over 10 years of experience in software development. I have a master's degree in computer science and unfinished PhD. And currently I'm working as software developer at Scope Technologies, using tools like .NET, SQL, JavaScript, and so on. And and I'm also a part-time lecturer at Riga Technical University, and I'm teaching microcontroller programming. And as everybody, I like exciting projects. And my hobbies include camping, geocaching, and nature travel. So that's about me. About the company I work for, so it's established in South Africa in 1999. Its main offices are in South Africa and Latvia, and there are sales offices all around the world. Basically, the company is involved in 4 main verticals, so it provides solutions for insurance telematics, fleet management, aftermarket, and consumer connected car services. And it entered telematics fleet management market in 2001, and it commenced activities in the insurance telematics sector in 2008. And so the solutions that are offered by Scope are exclusively designed and produced by our company, and the products are backed by extensive patent portfolio. So basically we have global patent footprint, and we were rated as one of the top telematics technology providers by some very important company. The companies that are using our solutions include these. Maybe you have seen some of these, maybe not, I don't know. It's just for reference. And so here is the worldwide coverage. So our partners are somewhere there in the blue. And what we actually do. We have cars that are driving around with telematics devices, reporting data as GPS data, acceleration, and so on. And the total goes down. It all gets to our telematic gateways, and then we process the data and reach it, analyze fuel consumption, analyze accidents, which I will talk about today, and so on. And then through billing system it gets routed. So this is another example of how it operates. So basically each car has some device installed into it. Through mobile network it reaches our servers. And basically from there we have several applications, such consumer portals, some value-added services like mobile applications. And what I'm going to talk today about is the claims management and accident reconstruction system. And what I'm also going to do, I am going to show you a video of our company. So like that. And we have no sound. But yeah, very good. You like the sound? It's very good. It was actually better Basically, overall requirements: be passionate, responsible, and trustworthy team player. And a very important thing is that you must want to make a difference, not just be a regular worker that just does his job and goes home. But if you really want to make a difference, then come join us. You need to be fluent in English and some other stuff you probably are familiar with. And so it's easy. So currently there are 3 positions open: senior .NET developers. You know what that means, yeah? So senior with a beard in a different color than mine, so that's senior. And if you have some experience, then come to us. Then we also search for mobile developers. You know, the mobile things you get out of your pocket and you can call. So if you want to develop something, you can come to us also. And if you want to test how these 2 men are working together, or women, so you can come and also be a tester. And so there is some contact where you should probably send some documents and maybe they will review. And enough of promotion, I'm going to talk about accident reconstruction. So if there was an accident and we have something like this, and the big question is, what happened? Very nice. So basically it consists of 2 parts. One is accident detection and another is post-factum analysis. So we need to answer questions like how to determine if a car has suffered an accident from the onboard telematic device. So we need some sort of trigger: hey, it was an accident. And also what are the properties of that accident? So how severe it was? Is human injury likely, or we just scratched another car and that's it? And maybe we can use this information to provide immediate assistance. Actually, we can do automated emergency call. Do you know what is the automated emergency call? So automated emergency call is if something bad happens to you, the 911 or 112 gets called automatically to your location. So you are relatively safe. Or maybe you're dead when they arrive, but at least they get called. No problem there. So, and the other is post-factum analysis. So accident verification. So is this what really happened? So that's mainly used by insurance companies. So because somebody gets and, hey, my car looks like this, I only one hit, nothing else, but judging by the telematic data, maybe he just scratched some other car and then went mad and smashed his own car with a hammer or something like that. So we need to verify what actually happened and how did this happen and why. Because if there is an accident, if it's lethal, for example, then everybody wants to know what happened. And our aim is to provide as much context as possible for a person to make an informed decision. Okay, so that's what we are trying to answer, and the changes in market demands about accident reconstruction. So firstly, they just wanted to know if accident happened and what were the impacted zones. So then they wanted to play the accident back, and then they asked, what about accident reconstruction in 3D? Can we view this in virtual reality using Oculus and so on? So how it evolved? So obviously you have some data, and if you have the data, you can mark the impacted zone on the car using some fancy mathematics, and that's good. Second way, okay, it would be nice to play back an accident. So okay, there are some charts, some timeline, you press play, something happens, you can also see what happened to the car. And what about 3D? Okay, we gave them 3D. So there is a 3D map of the world, and then street view, and other fancy things, which I'm going to talk about tonight. So how it all started? Basically, we had these. So it's an accident playback. Can you tell me what is the problem with this picture? Anybody?
Not sexy.
Not sexy. Yeah, it's not a woman, but Yeah, so it's not sexy. And why it's not sexy? Because there is no context. So where was the car driving? What are surroundings? What actually happened? And judged by this picture, you can't tell. And so the question arises, what we can do? What if we could make the car actually drive on the road? And what if we could include some physics to make like car roll over and so on? Can we do it? We can just conclude that we need to place the car on the road and incorporate physics. Well, good, but how? And that's how. First, we need to place the car on the road, we need to display spatial information in 3D. Who knows what is spatial information? Spatial information is geographic data. So the data from which you draw a map. So and we need to display that in 3 dimensions. So where do we get map information or spatial information? Well, the most popular choice would be like Google Maps and API. Who has used Google Maps and API in their project? Anybody? So a few people have. So you know, there's Google Maps. They provide map tiles, so the image of the map. They provide street view. They provide speed limit, and so on. They provide some things. So the obvious choice, hey, Google Maps, we just pay them lots of money and they give us a service, no problem. So obviously, map tiles. Have you seen this? Yes. So somewhere over the internet, there is street view. That's also a map. Okay. And then there is the theme snap to roads. Who knows what snap to roads is? Some people know. So what is snap to road? So when you have a GPS device, you will get data like this red line. So you have one point here, next point here, and so on. And if you want to do some playback, if you do two-dimensional playback, okay, the car is driving over something, it's okay. But if we imagine if you're doing 3D playback and car is just driving through all the buildings, it's not good. And so, for example, Google provides a service called Snap to Roads. It's obviously a premium service and you pay everybody money to get what you need, but we can actually snap these points, the red line, to become this blue line. So it snaps the points to actual roads. And so it's very, very useful if you need to do something precise with the map data. Okay, so we have these elements. Well, obviously there is speed limit, but I think that's self-explanatory. So what of the above can be used to create 3D environments. So as I said, there is snap to roads, so we need adequate positions. So we don't drive through buildings, but we drive on the road. Then there is Google Street View, which can provide both 2-dimensional and 3-dimensional images. And let us see how. So there is Google Street View in 2 dimensions. And basically there's a single call to document Google API. You input your location and your orientation, and you get an image. It looks like this. So if you have internet in this box, I can demonstrate this to you. Who has used this API? Oh, somebody has. Good. So if you put into your browser this link, you have image like this. So if I change, for example, my heading, let's say 45 degrees, and press enter, I get the same position, just a different time. And so if you feed this to Google, you can get like an image. It's very easy to implement, and it provides visual context of the surrounding environment. But what's the problem? You get a 2-dimensional image, and it's actually not real 3D. And it's also not a real-time solution. So if you programmatically try to change these pictures quickly enough, there are 2 problems. First is Google limitations, and second is it doesn't appear so fast as you would expect. So we need something else. And it turns out that Google has some undocumented APIs, but if you Google for them, you can find them, but not in Google, but some other site. And you can actually call Google API to get panorama ID. So what is panorama? Panorama is like 360-degree view of something. So you can get the idea of panorama by location, and the panorama consists of multiple images. And you can get all panorama parts together and create a unified panorama image from that. And when you have this image, well, okay, it's beautiful, you can show it to your mom or somebody else, but to make it of some use, you can apply it as a texture to a 3D sphere object. And if you place the observer inside that sphere, you have a 360 street. So, but you say, hey, it's invented already, but why is it better than default this way? Because we have full control of what we do. And we can include additional information, like 3D model of the car, like draw the trip, and so on. And we also can make it a real-time experience if we switch spheres quickly enough. You can taste the real-time experience during breaks in our VR stand there. But it works. So picture says 1,000 words, so actually you can get from Google all these small images of a single panorama. Then using your programming skills, you can assemble one image of that, and then you can apply it to a sphere. It's not the same image, but I hope you get the idea. So you have a three-dimensional sphere, you apply it as a texture, and if you place on the camera or the observer inside, so you have like, wow, 360. Okay, we have 360, but what about 3D? So it's not 3D, it's just 360. So you can look around, but there is no 3D. It turns out that Google has another implemented API that provides distance from the Google car. You know, the fancy car that drives around, that makes photos of everything. It also has a laser on it, and it doesn't shoot people, it measures distance with the resolution of that, of the spherical image. So, and we can use this information to transform the sphere. Imagine we had a sphere with the image, yes, and we can transform the geometry to make it real, 3D. So this is how a transformed sphere looks from the outside, but from the outside it's not so interesting. We need to take a look inside. From the inside it looks like this. Well, it's basically a flat image on this monitor. It's very 3D there, but what is the difference? So actually closer elements are closer and vice versa. Well, it's very hard to show in this picture, but maybe you can see that buildings are actually closer. Obviously there are some glitches because not everything is perfect, but what it gives is you can actually move. You can walk there, you walk forwards and backwards and so on. And this is a real-time experience, and it's best viewed in VR using Oculus Rift right there in code. So, okay, we have that. So we have Street View, and if we use also snap roads, so we can provide a pseudo-realistic environment for accident players. Everything's good, but there are these problems that Street View is not available everywhere. For example, Costa Rica has no Street View at all. Germany has very limited Street View because of the censorship and privacy and so on. And obviously the images can be several years old and contain large censored sections. So as anybody who uses Street View, you see and you search for a specific shop, you say, and you like turn and everything is censored. Have you seen that? Yeah, so everything's censored, you can't even read. And imagine you're doing 3D playback and there are just censored everything you don't see. Yeah, so obviously displaying the Street View in 3 dimensions is resource and bandwidth intensive, and it's not applicable for every use case. For example, mobile phones, if you go to like outside big cities and you want to display like 8 megapixel images switching around every second, well, it's simply not work. And obviously quality can vary, but the most important thing about Google is that spatial data itself is embedded in images, in map tiles, in Street View, but you cannot ask Google, hey, dear Google, give me all the buildings, their coordinates, give me all the roads, their coordinates, and I want to draw them myself in 3D. So you can't ask. Well, you can ask, but you won't get an answer. What to do? We need to look somewhere else to create appropriate 3D representation of the world. And yes, that's what I said. We need to look somewhere else if you need anything beyond basic images. One option, well, there are lots of options, but I'm not going to talk about them, at least in my presentation time. So one option is OpenStreetMap. Who has heard of that? Oh, many people have heard. Very good. So basically what it is, it's a database, open source and so on, consisting of lines, polygons, and points, which represent the appropriate structures of the map, such as points of interest, like hospitals, coffee shops, buildings, roads, and so on. So everything is there. So, and what is the big, great news? This data is available for everyone for free. So just go and grab a Planet file with minutely updates, which is only 30 gigabytes. Import into the database is only 600 gigabytes, and it will import only 40 hours, so no problem there, but you can do it. And obviously, if you don't have like several $1,000 worth server, you can extract some small country like Latvia from here. You just download the data. Latvia is 100 megabytes. In comparison, for example, Germany is 3 gigabytes, but it's just the data file. The database is like much bigger. And okay, you get your data, and then there exist a number of open source tools and tool chains to import this data into various formats, such as databases, some POST and GIS. Has anybody heard about this beast? Somebody has heard. Okay, so there are some beasts like POST and GIS and database, and so you can integrate it there and get the data eventually when you need. So what is the standard usage? So how normal people use the data? So I'm not normal, but how normal people use. So they download the data, they import it into their local database, and they use a tool to render 2D map tiles. And you can have your own map server at your home PC actually. In theory, well, your PC is probably not performing enough, but you can actually post the map tiles yourself. So you have it here. So you don't pay to Google, you pay just your electricity. Okay, so how it looks on the chart, yes? You see these charts somewhere in work or university, yes, but they try to draw some things and explain how things work. So you have this public OpenStreetMap data provider, you just download these files to your local disk, use some black magic to import data and updates into your local OpenStreetMap database, and then there is also a black magic called tile rendering, and so users connect to your site and they can get on that. So everything's great. But how we use it? Instead of rendering tiles, we create a special data access layer that extracts data as geometries. And we use a 3D engine to draw these geometries in 3D spaces shrink. So it looks like this. So we also download files to local disk, black magic, and so on. And then we have a special data access layer, and we have a 3D application, and users can actually view the map in 3D. So how it looks. So here is a standard OpenStreetMap black and white style. Somebody has seen it. Yes, somebody had. So there is some line and some trip, obviously. Obviously it's not snapped to roads, that's why it drives to the buildings, and we are here, so nothing fancy, yes. And here's the same location rendered in 3D. So, also same point. Well, there's supposed to be a car, but the screenshot is from a bugged version where we bugged the car, so I couldn't take it back when I needed to create this presentation. But the car is supposed to be somewhere there. But it's the same plate. So if you compare, this small region is rendered here in 3 dimensions. So we can actually use the OpenStreetMap data to render both 2-dimensional tiles and to also draw something in 3D as we want. And if we put everything together, so we can have something like this, where we have our Google Street View in 2D or 3D as we wish. we can have our OpenStreetMap tiles here, and we can have our trip or accident be played back in 3 dimensions using the data. And obviously, because we have OpenStreetMap database, we can use things like geocoding or reverse geocoding. You know what is geocoding and reverse geocoding? Somebody knows. Reverse geocoding is basically you have a location with longitude and latitude, and you can get a description of that location. So we are currently in Germany and some number street and so on. So we have that. So what do we have? We have Google Street View in 2D and 3D. We have map in 3D. We have map tiles. So we have it. So a car can be placed in 3D environments. We are providing, and which is actually very important because we are providing the context of the surroundings at certain location. So if you have to make a decision about what happens during the accident, you can actually look at the environment where it happened. So, but what is missing here is actual accident details. So what we don't have car rotation, deformation of impacted zones, and so on. Basically, we're missing physics. So what about physics? Physics in accident reconstruction. Okay, so actual physics of a car is very complex. Who remembers physics lessons in high school? Anybody doesn't remember? Only one person remembers. 2 persons remember. So everything is forgotten. I forgot that myself. I just remember that it was complex. And especially if we have non-deterministic situations like accidents, so everything is complex, and we actually would need to have precise properties of every screw to create the appropriate physics model. And the most important problem is that there are initial unknowns, such as impact or properties. So imagine if you are hitting a rabbit or you are hitting a brick wall. So the telematics data, for example, from the accelerometer might even look similar, but we don't actually know what the car hit until we don't see. And there are some problems, but that doesn't mean we cannot approximate. And basically, if we have some accelerometer and other sensors, we can have car rotation and approximate the formation of impacted zone. So rotation of the car is defined by 3 rotation angles, 1, 2, and 3. So one is roll, one is pitch, one is jaw. So it's illustrated better here. This is roll, this is pitch, and this is jaw. So 3 angles, basic feature. Yeah? Accelerometer data can be used to calculate this roll and pitch. We can determine jaw angle using magnetometer, gyroscope, sensors. So we can have it. And as an example, so if we have some data set and we run it through our 3D engine, so we can have something like this. So the car actually boom, boom, something happened, and it's actually like that. So we can display it, so more context. About the formation of impacted zones. So we rely on telemetry only. It means we have only the data that onboard device on the car sends. So we cannot determine some factors such as impacted surface area, as I explained. I don't know if we hit a ball or hit a ball. So without some feedback, or at least seeing the images of the actual crash. So we're doing our best to provide adequate approximation based on the telemetry data. And what do we possess actually? We have impact angle and we have impact magnitudes. And how can we use that? If you have a car 3D model, you can adjust the geometry by moving polygon vertices. And you can use things like shaders. Somebody has heard about shaders. Something shady, yes? So you can use something shady to change color of the affected triangles. And it basically looks like this. So if we have a car 3D model, we know the angle, we can bend in the appropriate vertices, and we can change the color. So you can see here how it works. And obviously a video is worth 1,000 pictures. I'm trying to show you video, obviously without sound, as we decided, so how it actually works. It's okay. So here you can see how the Google Street View actually works. So it's not Google, it's ours. Well, data is from Google, but we created this. So you have actually the feeling that you are moving in this 3D environment. Obviously, there are some glitches because nothing is perfect. And boom, here we have an accident. And here we have a 3D model. And here you can see something is bended. So the car hits something actually. And you can see that the car is not straight on the road. So it's actually, we have this rotation. So you can see that for yourself in that corner, as I keep repeating. So there is some other accidents. I just will show you. So here also the car is driving. So actually the car is driving. There are some fancy trees or something. So here you can see it starts slipping. You can see also this from the car movement. So it continues slipping and there is boom, something hits the car. And it stays in this position. And you can also see the impact of the zone, so that the car is resolved in the accident. And I have another video, which is basically all the same. I just think it looks good, so that's why I show you. Also a street view, so we're driving out of the tunnel. So you can see how this street view actually can be done in 3D. It's not perfect, but it's better than nothing. So we also have the 3D model, and you can also see maybe when this car starts like, so it starts speeding here. So you start speeding, then you're going to crash. And this is exactly what happens. See, if you're on a bridge in London and boom, we have an accident. So yeah, that is how it works. So this is a demo video. So it's almost everything I wanted to say. I just wanted to remind that we are hiring. So if you want to be a part of our beautiful team and work together, maybe even with me, and to develop software like that, and not only like that, because we have lots of software to develop. So you are welcome to join our team. And as Einstein has said, the important thing is not to stop questioning things.
Do you have any clients in Latvia? And if so, can I turn your services off?
No. So we operate on 50 countries worldwide, but not in Latvia. In Latvia, it's just us that do it. So,
how long does it usually take for an insurance company to create such a model?
So this 3D model, it's created automatically from telematics data. So we receive telematics data from the car, and if our algorithm decides there was an accident, we flag it properly, we get the information, and in 3 to 5 minutes after that, you can play it back.
Do you have some success stories like they created the model and found out some details that just allowed to save money?
I don't believe I can speak about that. Maybe we can take a beer and speak about it afterwards, but not about that.
I mean, it's very difficult to imagine a situation that this can affect some real decision based on money.
But the thing is, we try to provide context. So, and it's better than you have something like that. But because usually what you have, then we have to return to the start of our presentation, of my presentation, and you have these. And that's it. You have no more information. And what we are offering this. So it's maybe can help.
In calculations, you presume the road is perfectly flat. At least it doesn't like that impression that the road is perfectly flat, and in real life the road isn't perfectly flat.
Obviously. It's what I wanted to say is not like perfect physics and perfect, as you can see, it's even not a perfect image. But we try to provide as much context as possible. And it's better than you see it from the street, and so on. So OpenStreetMap actually provides the kind of information, but it's not always popular. You know, the null values in the data, so it's full of them. Yes.
Well, actually, it's connected to what you just said. How safe you feel that you're relying on undocumented API and on OpenStreetMap, which is actually inaccurate in a lot of ways.
So the undocumented API we use only for this Street View image in 3D. So we can have 2D image, you can have a 3D image. Well, it works currently.
Yeah. But do you see any kind of way of improving? You know, just because you're relying on third-party services.
So obviously, if we had, we can rent Google cars, install better cameras on them.
It's just obvious.
Yeah. And maybe, nothing better that we can do.
Okay.
How do you get telemetry data from a car from which device the car? Because a car by itself don't write anything, and until it is a Formula 1 car. Yeah. So where do you get this data? It should be some navigator inside.
Yeah. Okay. So maybe it wasn't clear at the beginning. So the cars, we actually have assortment of devices that can be installed in cars, and some of our clients, which we target with this accident reconstruction, they are basically insured. So if you want to insure your car and you want like a premium discount, we just install a device. Not we are service providers, so we're not insurers. We sell this insurers. So insurers install devices into their customers' cars, or they can be our devices. We brought our own devices. We can use third-party devices. So, and the devices are communicating with our platforms. So, and the device can gather, if it's installed, for example, now it can be seen too clearly, but if that device is installed in the OBD port, which is usually under the wheel somewhere, so it can connect to the OTP and collect data from the car itself. Obviously, it has internal sensors. It has accelerometer and something else, but it can also collect data from the car and use that for this.
I've heard there's a lot of different devices that insurance companies tries to put from their insured cars. However, do you have any competitors with creating such a model application?
Do we have any competitors with this model?
Is anyone in the world that has such a system?
Well, I don't know if anybody has created a 3D accident playback, but so I'm just the guy who stands behind the monitor and programs that stuff. So you should ask to the people in the food chain which are up there. So they're
It looks quite unique.
Yes, but there are services and there are services where you can actually have the accident reconstruction, but it's like you have in a 3D modeling environment. So you say, let's put a car here, let's put a house there. They have advanced physics and so on. But what we offer, we have telematics data, and the accident happens, and boom, after like 3 to 5 minutes, you can actually play it back in 3D. After that, you can go with that to somewhere else, but it's like a context that we provide soon after the accident. Well, we hope so.
I think there might be a case when a report from such telemetry device might conflict with police reports or with reports from bystanders who saw something visually. So when investigating such a case, do you know if this telemetry report is taken as more important or less important than other reports?
So, as I said, we do lots of approximations, and it's better to provide something than nothing, but obviously wrong information is sometimes even more. So we are trying to balance on the plate you mentioned, but this I don't know if these can be taken as series F. At least the 3D representation. Maybe the data can, but as I programmed it myself, no, it's not that.
It seems that it's time for chocolate and wine.
Yeah.